So in our next section, we're going to talk about mean, median, mode, and range. So at the beginning of this chapter, I said, hey, you need to have this like general understanding of statistics. So statistics is the process of collecting, organizing, and analyzing data. Okay, so we've talked about the kind of like organizing it using visual representations. Now we need to talk maybe a little bit about analyzing it. Okay. So we have the mean, the median, the mode, and the mid-range. These are really basic ways to kind of get some information about your data set. Two specific things that we're going to look at are measures of central tendency and measures of dispersion, or in this case, measure of dispersion. Okay, so measures of central tendency are statistical metrics used to describe the center or typical value of a data set. So ways to kind of find out like what is the most common data item. That's one thing we can look at. What is the actual middle of the set, or what is the average of the set? So those are all measures of central tendency. Sometimes you'll see a fourth one called mid-range, but we don't really have to cover that one. If you are interested in understanding what is the mid-range, in the mid-range, you take the highest, add it to the lowest data item. So like literally what's the smallest data item in your set, what's the largest data item in your set, and then you divide by two. So that's another measure that we don't really have to talk about in this book, but that is one that you would see if you take another statistics class potentially. Okay, so the common measures for us are going to be mean, median, and mode. Now, measures of dispersion, we're only going to talk about one, but measures of dispersion are statistical measures that describe the spread or variability of a data set. So a simple measure of dispersion is the range. And so we're just going to look at the range one here. There is something else called the standard deviation that you would talk about in potentially other math classes, okay? But it's a little bit beyond the scope of what we're going to do here. Okay, so we're going to look first at the mean, okay? So the mean, let me get my highlighter back out. The mean, often referred to as the average, is found by adding all of the values in a data set and then dividing by the number of values that you have, okay? So you add all the data in the data set and then you take whatever that sum is and you divide it by how many numbers were in your data set, okay? So outliers, this is something we need to talk about, and we're not going to go deep into what outliers are, but outliers are values that are especially large or small compared to the rest of the data set. And what you do need to know about it, outliers, or for us, maybe not so much outliers, just kind of values that are a little bit far from the rest of them, sort of more extreme values. The mean is going to be really sensitive to these. So essentially, if you have a bunch of data items here, and then you have this one little guy way over here, your mean is going to get pulled towards that extreme outlier value. Okay. So just know that your mean is a really good measure for the center of a set of data. It's the average. Okay. But it can be sensitive to extreme values, either high or low. Okay. So let's look at some examples here. So example one says each set of data contains 5 exam scores. Find the mean exam score for each data set. Okay. So to find the average, you quite literally add up your data items and then divide by how many items you have. So we would say, okay, the mean, you'll sometimes see it called X bar. Okay, so if you were to take an actual statistics class, or even if you took like quantitative literacy, you would see this potentially called X bar. We're just going to go ahead and say, hey, the mean is going to be just whatever. Okay, so we could call it X, we could call it M, we can call it whatever we want. We're not going to get too fancy here. Now, what we need to do is we need to add up all of our data items. So we get 78 plus 74 plus 70 plus 75 plus 72. And then we want to divide by the number of data items in our set. Well, we have 1, 2, 3, 4, 5 data items in our set. So we're going to divide by 5. So if you have not gotten your calculator out, pause the video now, go get your calculator. All right, I'm not going to bounce back and forth to the virtual calculator just because it'll be too much bouncing. Okay, so we're just going to use our handheld set here. So we've got 78 plus 74 plus 70 plus 75 plus 72. Let's double check our numbers. 78, 74, 70, 75, 72. And I get 369. And then I need to take that and I need to divide it by 5. And so we get that the mean here is 73.8. So this is a way to measure the center. We kind of take all the items, add them up, divide by how many items we have, and we get an average. So the average test score here is 73.8. That kind of makes sense. You got a couple of data items bigger than that. You got a couple data items less than that. You've got one data item, 74, that's almost exactly that. This makes sense. It kind of represents the center of this data set. Okay, so the average here, 73.8, or the mean score, 73.8. Let's look at our next set. So when we look at our next set, we have 78, 74, 70, 72. So four of the five data items are kind of close together. They're very similar in nature. Then we have 100. Okay, 100 is quite a bit bigger than the other four data items. So let's see what that does to this set. So notice the sets are the same. They're 78, 74, 70, 72. The only one we're switching out is 75. We're changing it with 100. So we're going to add again. So we take 78 plus 74 plus 70 plus 100 plus 72. We divide by 5. So let's see what we get when we add. So again, if you haven't gotten your calculator out, what are you waiting on? Get your calculator out, okay? So we have 78 plus 74 plus 70 plus 100 plus 72. So this time I get 394. We need to divide that still by 5. And I get 78.8. So notice here we have 78, we have 74, we have 70, we have 72, but our mean test score is higher than all four of those. And the reason for that is this 100 pulls the mean up. Okay, so 78.8 is sort of unrealistic. It's a little bit inflated. Okay, so that score of 100 kind of pulled the mean towards it, and now it's higher than all four of the other data items. Okay, so you can see while it's technically measuring the center, it's giving us this idea of an average. It's not maybe the best representation because that one data item of 100, which was bigger than the rest, it pulls the mean up. Okay, let's look at part C. So for part C, we have the same data set for the most part compared to what we started with. We have 78, 74, 75, and 72. We're swapping out the 70 with a 30. Okay, so what do we think that 30 is going to do to our mean? Well, if it's anything like the 100, it's going to pull the mean towards it. So this is probably going to pull the mean down. So let's see what this does to our average. So we've got 78 plus 74 plus 30 plus 75 plus 72. We want to divide by 5. So 78 plus 74 plus 30 plus 75 plus 72 is 329. And we need to divide it by 5, and we get 65.8. Okay? Well, 65.8, if you look at our data items, 4 of the 5 data items are higher than 65.8. And ideally, if we have like a set of data that's kind of evenly dispersed, we would see that, you'd have half your data items above the mean, half your data items below the mean. But when you have that one extreme value that's like way higher or way lower than kind of like everything else, it will pull the mean towards it. So this value of 30 really pulls your mean down to where it's lower than almost all of your data items, okay? Now, it is still technically the average. It is still technically the mean, okay? For the mean, we include all data items, but you can see how the mean is kind of sensitive to those extreme values, okay? So just be on the lookout for that, okay?